Hi, my name's Rosalinda, and today I'm going to be going over a lesson from week 1B. This is going to be question number 2. A plane is awaiting takeoff on an adjacent parallel runway. Another plane lands and passes at a speed of 29.0 meters per second. The arriving plane has a length of 32.8 meters. When looking out the window, for how long a time is the plane visible? So I drew my little picture here so that way you can see the little planes are just going to be adjacent to each other. So you want to see how long the moving plane is visible through the other plane. So again, we'll start with what we're given, which is that the arriving plane has a length of 32.8 meters. We also know that the arriving plane passes at a speed of 29.0 meters per second. So we are going to, again, what we were given, it was the length of the moving plane, which we will use as our distance, is going to be 32.8 meters. We will use the speed of the moving plane as our velocity, and that is going to be 29.0 meters per second. So then we will use the formula time equals distance over velocity to get a total of seconds that we know the plane is visible for. So that's going to give us a total of 32.8 meters over 29.0 meters per second, which will cancel out the meters, and we will divide, which will give us 1.13 seconds is how long the plane will be visible for. Hi, my name is Rosalinda, and today I'm going to be going over a question from week 1B. This is question number 5. Electrons move through a certain electrical circuit at an average speed of 2.3 times 10 to the negative 2 meters per second. How long in minutes does it take an electron to traverse a 1.6 meter light bulb coil? So I just drew a little picture to show that it takes about 2.3 times 10 to the negative 2 meters per second to travel down. And if we have a 1.6 meter coil, how long will that take to travel down? So we are given our average speed, which we will use as our speed, as our velocity, and it's going to be 2.3 times 10 to the negative 2 meters per second. And then we are given our distance, which will be used as our distance, and it's going to be 1.6 meters. We'll use the time formula, which is time equals distance over velocity, and that will give us the 1.6 meters over 2.3 times 10 to the negative 2 meters per second. The meters will cancel out, and that's going to give us a total now of 69.565 seconds. We know that 60 seconds are in 1 minute, so we have to multiply 69.565 seconds times 1 minute over 60 seconds. The seconds will cancel out, which will give us a total of 1.159 minutes, and that is how long it takes to traverse a 1.6 meter light bulb coil.